Hi, welcome to this tutorial on the normal distribution. Now in this particular tutorial, what I'm going to be showing you is how to work out the probability of being more than an observed value x when that observed value is greater than the mean mu. And in order to do this, it's best if we run through an example. Now here's the example. The masses of a well-known brand of breakfast cereal are normally distributed with a mean of 250 grams and a standard deviation of 4 grams. Find the probability of a packet containing more than 254.4 grams. Well, the first thing we need to do is to define a random variable x, and so I'm going to say that that random variable x is going to represent the mass of cereal in grams, where x is distributed normally with a mean mu, as we often say, mu of 250, and the second parameter is the standard deviation squared. The standard deviation is often called sigma, and we are squaring that, and that becomes what we call the variance. So if we square the standard deviation of 4, we get 16. Now I need to draw a sketch of the normal distribution for the random variable x, the mass of cereal in this case. And the central value represents the mean, and that will be 250 grams. So we've got 250 there. And we're looking for a cereal containing more than 254.4 grams. So I need to place that observed value on the graph, so we'll imagine then that that is the point 254.4, and we're going to call that the observed value, little x. Okay, random variables have capital letters, observed values small letters. So what I'm looking for is the probability then of being more than this particular value. So in other words, that is represented by this area here, which I'll shade in. Now, in order to do this, what I've got to do is standardize this distribution. So I need to draw another normal distribution below it. The standardized variable is the letter z, where z is normally distributed with a mean of 0, which I'll mark in here, and a standard deviation of 1, which when squared gives us the variance of 1 squared, which is 1. So we have z follows a normal distribution, mean 0, variance 1. And what we do is we project this down here, okay, and work out this corresponding z value. Now z represents the number of standard deviations that the observed value is above or below the mean. And to work that out, we use this formula, which you should already know, which is z equals the observed value minus the mean all over the standard deviation sigma. And if we apply that formula then to this question, we've got the observed value, which is x at 254.4, so 254.4, minus the mean mu, which is 250, so minus 250, all divided by the standard deviation sigma, and sigma, the standard deviation, is 4, or the square root of 16, so we have 4 there. Now if you work that out, what you should find you get is a 1.1. So what that means is that this value here is 1.1 standard deviations above 250, the mean 250. I mean, one standard deviation is 4, okay, and 0.1 of a standard deviation would be 0.4. So that would be 4.4 if you went 1.1 standard deviations above. And you can see, if you add 4.4 to 250, you get 254.4. So 1.1 standard deviations then is this observed value above the mean, and that's represented by this z value. So what we need to do now is just work out then the probability that x, that is the mass of the cereal, is more than 254.4 grams. And that is represented by this area here, which is exactly the same as this area here. So it would be the same as working out the probability that z is more than 1.1 standard deviations above the mean. Now we need to use cumulative normal distribution tables, and what I'll do is I've just got an extract from the tables here. You'll find these tables normally in the back of a statistics textbook or in a formula book, and what we have is the z values down here, and we've got a typical graph of the standardized normal distribution here, where phi of z, which is the same as the probability of z being less than a given value of z, is tabulated, and that's represented by this area here. The problem is though that the z value that we have, 1.1, okay, fair enough, it's to the right of 0, but we are given this area over here. Let me just show you by way of a diagram. We'll put a margin down through here, okay, and separate this off. What we've got is this area here to work out where z is 1.1. But the tables only give us this area to the left of any z value. So we can get around this problem then, knowing that the whole area comes to 1. We can say that this is the same as 1 minus the probability of z being less than 1.1. Now, z being less than 1.1 we can write as phi of 1.1. So you could write this as 1 minus phi of 1.1. And from tables, the tables that you see here, all we've got to do is look up 1.1, the z value of 1.1. And if we come down here, 1.1 is down here, and the corresponding phi of 1.1 is the value 0.8643. So 1 minus 0.8643. And if you work that out, what you get is 0.1357, and we should really round this up to say 3 decimal places, not leave it like this, because the tables are only 4-figure tables and they've got other values behind these. So to guarantee the result 3 decimal places, we would have 136 to 3 dp. Okay, 0.136 then is the probability that x is more than 254.4. So hopefully you'll be able to model any similar examples that you have to this example. And that brings us now to the end of this tutorial.